Good afternoon, everybody. My name is Raphael, or to make your teeth cracking a bit easier, Rafi. I'm a system programmer at Intel, and what I'll be presenting to you today is KVM on a grid, shaken, not stirred. You'll have to excuse me, this is the second presentation I've ever done in front of an audience, and it's my birthday today. So please try go easy on me. I'll try not to speak too quickly, which I tend to do, and you can stop me at any time, questions and so forth. It's odd hearing yourself. Okay, so let's get things going. Here with me is my co-author, Igor, who's got a tremendous amount of credit, and we work together. So first and foremost, not really, but legal warnings. So Intel disclaimers, all kinds of interesting stuff. If you'd like, we can go over the exam tomorrow, but you can read anything you like. It's a legal requirement, so I'll also give just one word. There's some things that we can't discuss because of NDAs and all kinds of, again, legal and lawyers, so you'll have to excuse me for skimming over a few things and maybe not giving, I'll say, giving a bit of ambiguous responses to some questions if you decide to ask. So what we'll be doing today is naturally giving a bit of background and information, and then diving into what the solution actually is, a small discussion on the results, and looking ahead. There were a few interesting ways of getting people to join in and participate, but I didn't bring any presents. But if you act nicely, then there are a few booths outside. They'll be glad to give you presents later on, and I hope you've stocked up on them already. So let's get things moving. So who am I? As I mentioned, my name is Raphael Sack. I'm a system programmer in engineering computing. And in a moment, I'll explain what engineering computing actually is. I've focused mostly on web and system-related development in Windows and in Linux. Yes, I said the W word, but focusing in Linux in the past couple of years, mainly system, web, and virtualization. I'm a car enthusiast, and actually we're going to be going racing at Spa in 2 days' time. And as you can hear, I've got a strong South African accent. Okay, another forced upon us slide, Intel IT statistics. Now, it might be interesting to some of you, but basically it's just some information and a nice guy working regarding some numbers about Intel IT. It's partially relevant to what we'll be discussing today. It's just to give you a bit of a magnitude and so that you can grasp the size of Intel IT-wise. It's a bit less relevant to what we're going to be discussing, but again, Intel IT globally are approximately 6,000 employees. Only in IT, Intel total towards the 100,000 mark. Again, the shift to virtualization, mobile, SSD, which is one of Intel's technologies, just to give you a perspective size-wise, and so that you can see somebody working. So now focusing a bit lower down on what we're going to be presenting today is Intel's chip design environment. As you may or may not know, that's Intel's expertise. Designing chips. So looking at the chip design, which is what the department we work for, engineering computing, we focus on supporting the chip design activities. What does that mean? There are many design, when I say design, I mean CPU design campuses across the globe. Our data centers span 40 of them. Gesundheit. It's exciting, 40 sites. So span 40 sites globally, approximately 600,000 cores. Might not sound much to you, 5 petabytes of memory, 24 petabytes of distributed storage, and so on. The interesting numbers here are 40 million regressions a month. Now, I presume most of the people here are programmers or something, so I don't need to explain what regressions mean, but it's a massive amount of work. And all that's done in the bullet above it via a distributed batch environment we have, an internal one. So basically, we're focusing on CPU designers, CAD tools, EDA, VLSI, and so forth, sending simulation and regression jobs all over the world. That's our main job, and that's Intel's main task, besides making money for the shareholders, is producing quality chips. And again, you have to remember there are some numbers we can disclose. I hope I won't say that again. Just one important thing to remember, when I say batch, I mean interactive and non-interactive. So non-interactive would be somebody firing up, I don't know, X 100 regressions saying, I'd like to see the result in a few couple of days. And interactive being somebody working on his VNC actually designing or emulating something, or even, I don't know, playing solitaire or K games. Okay, so what is KVM on a grid? Actually needed a pointer. So we were looking at the way our environment works today at Intel, and we saw two very interesting realms, one of them being virtualization and the other being our batch system. And both of them, without flattering ourselves too much, are extremely developed, but we didn't see that many meeting points. And I can't tell you why, it's just a fact. Both of them were very developed, but each one in its own realm. So what we did was decide to try connect them. So one of them is again, the design of the chips and all that, the cloud system that supports them and distributes the jobs, manages the workloads, reports back to users, and so forth. And the other is the side of virtualization. So our solution provides, and it enables us to rapidly transform the environment OS-wise. It provides seamless integration for the users, which is usually the most important thing, because a user just wants to work. It allows users, whether they request it directly or indirectly, to spawn nearly any operating system they want via a click. And when I say click, it can also be command line or API and so on. It gives us on-demand provisioning, and as I mentioned, seamless integration, which is maybe the most important thing from a user's perspective.
Excuse me.
Sure.
How does it differ from cloud orchestrators like OpenStack or things like that?
So you have to just remember that there's a breadth of open source and proprietary clouds out there, but many very large companies build things, suited, tailored to themselves. I can't, again, discuss exactly what's inside the cloud, but you can equivalize this to any system you see. Just the main point I'm trying to present here is the fact that we have a cloud solution, but you're looking at, again, from a computer science or whatever you like, IT perspective, at a cloud. You're saying, you've got OpenStack, you've got VMware Cloud, you've got so many solutions, AWS and so forth. But you have to remember that this cloud its main goal isn't compute, actually, it's to provide compute for design customers. So they don't want to, test Fedora 12 or, run a simulation, fiddle around with Red Hat. They just want their simulation, which at the end, a regression is a design of a CPU, trying to emulate and find potential issues in it. I hope you're looking at it from the compute perspective. They look at it as we need capacity to run a job being a task, a simulation. So this cloud, internal cloud, is just optimized for them. It's catered, I wouldn't say tailor-made, and there are quite a few companies across the globe that do similar things. I don't know where, I can't see from this distance, but wherever you work, you might take something off the shelf and tailor it, or you might say, okay, I'll start doing it myself. Okay, so why do we need this? Operating systems. The enterprise sees a new release every couple of years. It's not the fact that we see, new Ubuntu versions coming out all the time or patches and things like that. Again, we're focusing on the data center environment and on enterprise. So when you get a new operating system, or image as we prefer to call it, how long does it take you to verify that image? And when I say verify, I can get back to what you mentioned. Configurations, customizations, your monitoring tools. Not everything is plug and play. You don't just take a new release, and you do when in the videos on YouTube maybe, or in the documentation from the vendors. You just take it, put it in, and everything works out of the box, and people are dancing around enjoying themselves in the office. But in reality, that isn't exactly the case. So it takes you time to verify the image, that it works with everything you've got. It takes you time to adapt to it or due to it. You might have to change some of your tools. You might have to go back to the vendor and ask for changes. And the main point here is it takes time to switch over, whether it be because of your IT, because of your users, because of, anything you like. You can't switch over in a second. It takes a while. And serious pain point we have is different types of customers dictate different timetables. One customer might be ready in a day, one might be ready in a month, one might never be ready. The problem you may encounter is support cycle. The vendor says this operating system no longer exists from my perspective, or I'm cutting down on the support. What do you do then? You still have to provide the users with a solution, and on the other hand, you actually need support from the vendor if something goes wrong. Eagle found bugs going back 6-7 years in kernels, which are still in use in many places in the world. I'll put it like this. It takes a juggernaut quite a while to move. And that can happen with any big company, be it a startup, very big startup, or a big company. So what can we do about this? Naturally, you can stay put, not making any changes. What there was, that's what there'll be. Another, seriously, no. We can accept no new hardware or technologies. I don't think so, especially as some of the technologies come in-house. We can leave the users no options. We know better. Users are only problematic. We say no more. That won't happen. Otherwise, we might have something else written on our paycheck. We can realistically maintain several images and machines simultaneously, which might sound ideal, but again, very big companies don't like maintaining very odd or old operating systems and hardware. What do you do if you've got an old box and you need to fix it suddenly after, I don't know, 5, 6 years? It's going to be difficult. It might be outdated. You might not even be able to get help you need to fix it. And the reality in enterprise, as a charming guy once put it, the long tail of support. As in many things in life and paradigms, the long tail of support. What happens is you might have one perfectly new operating system which you're focusing on, but you've got endless amounts of older distributions, kernels. I see somebody smiling, so I hope it's good. You feel me. So the ideal state, no specific operating system dependency. In an ideal world, go into, I don't know, I can't use names, so distro.org, download the latest one, distribute it, finito la commedia, everything working. Not really. Infinite on-demand capacity, unless your money grows on the trees, I don't think that will ever happen. Be able to change operating systems immediately. I wish that on you. I don't think it will really happen. One size fits all operating system, no, nothing else. Or ideal state for us is to go visit the Nordschleife. So instead of that, we're going to Spa, but that could be ideal. So seriously, we're dealing with customers. Things aren't that easy. You don't say no operating system, no hardware for you today. Nothing of the sort. So our solution, sorry for reading the presentation, but I'm a bit excited. Extend the batch cloud system to support virtualization. Make the virtualization as transparent as possible for the users. What does that mean? Again, you might have a user, I don't know from which backgrounds all of you come, or what kind of companies, but you may have a user who's a technophobe or a techphile who might actually be interested in what's going on behind the scene. I'll tell you a secret. Most of the users you will encounter couldn't care less. They just want to do their job, make sure the work gets done, and they don't want any headaches beyond that. So we wanted to allow the users to still be able to choose the operating system of their liking, but that's only if they need to. If you know that there's a user using an ancient application which requires a specific operating system, don't burden them. We'll decide it for you. But on the other hand, if you have somebody who specifically would like to test or use an operating system, give them the option to choose it. As I mentioned previously, this is both for interactive and non-interactive usage. And one of our, from the IT perspective, our main pain points is to limit the use of older operating systems. We're giving them an option to use them. We don't want to encourage it too much. You want to try and slowly move out of these old operating systems. A bit of blasphemy, yes, running Windows and Linux. Again, second time I've used the Windows word, but it does exist, and that's a very important option for us. Again, you may be familiar with other clouds, different solutions, but in a heterogeneous environment, it's very important for us to be able to run either or and not be limited in any way. And just because everybody likes using the word one lately, so one cloud. We don't have, I don't know, you mentioned OpenStack, so we don't want to have one instance for this, one instance for that, or differentiating between customers, operating systems, distributions, and so forth. So, a drop of architecture. Again, a small disclaimer. Intel graphics, I don't know if SVG or how advanced, but they're dictated to us part of the template. The little guy in blue doesn't have actually the blues, but he's an employee. And what he's doing is he's sending a task, and excuse me if I mix up task and job, it just depends what you actually do daily and what you call him. But he'll submit a job to the cloud. Our scheduler will then start deciding and analyzing where's the best place for that job to land. Then it will consider whether or not this is eligible to go virtual. At the end, it will decide where to land it on a physical host. An important note is that on this physical host, what we're doing is trying to give as much potential as possible for this virtual machine to run best performance or in the best possible manner by using anything we have at our fingertips, be it SSD, the latest architecture, better or best networking capabilities, and so on. I said networking, your computer went haywire. Yeah, she's jealous? Citrix. I don't know what that is. So then what happens is the task is inserted into the virtual machine, and I hope the last time I'll be mentioning this, the user interacts with that task seamlessly. They don't know, they won't know whether or not it's on a physical machine or not. They just know you submitted your 3,000 jobs, they're running, you'll get the responses, you'll be able to do whatever actions you like with it, I don't know. Everything is fully transparent. So a slightly lower level architecture, or higher, depends where you're looking at it. We've got the cloud agent, and we've got the KVM manager. And I'm using KVM manager here, not in any, I don't know, a virt manager or whatever. It's just a name we gave wrapping the virtualization, the underlying KVM virtualization, with an encapsulation meeting our cloud's requirements. So what happens is basically the cloud has its interface, and the KVM manager encapsulates the KVM logic, and then those two can connect. And then basically you can also use any different hypervisor of your liking or any other mode of interacting with KVM fairly seamlessly. So the KVM manager handles everything to do with the hypervisor and the logic, additional logic we'd like. So once the cloud agent on the local host has received this task, it will then interact with the KVM manager, allocate capacity, fetch the template, and by template I'll clarify what I mean. It's a specific operating system, customization, and configuration. So I'll call it a template, but basically that chunk has everything required locally to spawn the relevant task. That's located in a central repository. You can fetch it any way you like, be it, I don't know, NFS, CIFS, a secure copy, anything you like. Then the KVM manager will configure and spawn the virtual machine, and at the end we have a virtual machine. The cloud agent interacts with it directly, and the user's task is injected into it. So again, the cloud agent, virtual machine, task running inside. So use cases. Software validation is the easiest one to think about, because basically you've got, let's say, a developer. I would point at somebody who isn't too sleepy, that would like to verify their application on more than one platform. That does happen, and maybe, I don't know, Windows 7, Wine, anything they like. So the easiest use case would be they send out a job, they say, I want it on A, B, C, D, E operating systems, fire it away. The next one is what we focused on previously in the presentation, was legacy operating system and tools. You may have a vendor whose tool is from, I don't know, 10, 15 years ago and still used. You may have an old operating system which you need to use, or that's your only option. Another use case. Throughput versus performance. So we have to remember we're dealing with a data center environment and business groups. Some of them, and these are bullets 3 and 4, some of them may be more interested in throughput, and some may be more interested in performance. So performance means get my task done as quickly as possible, shave off 2 seconds, I'd be happy, shave off 10 minutes, I'll be more than happy. Others might care about throughput. I want as many of my jobs running simultaneously, because performance is less of a matter for me. And that's more important when we're talking about short-term capacity needs. Now, any one of you focused since the beginning may say to yourself, but your Intel, you've got 600,000 cores, 5 petabytes of memory. What's the problem? Go make another chip, use it. But we have to remember that in such a big organization, you still have business groups. And capacity allocation works, I don't know, mysterious ways. Not everybody has as much capacity as they like, even if somebody else may have some free capacity somewhere else. There's still the matter to manage these things at a business group level. So if somebody suddenly needs this capacity on demand and they can't start planning to buy, I don't know, borrowing from a friend a laptop or something, just joking, they may want to use this option. Isolation. So the latest, for the past 2 or 3 years, the buzzword is containers. So what we wanted to actually avoid, one of the main points would be to isolate and contain users. Not literally, naturally, but we just want to make sure that if a user abuses the machine, or, I don't know, their task gets out of hand, that other users won't be impacted, or to minimize the impact. Now, in non-interactive, you may say it's not the end of the world, but it actually is a bit, because some of the tasks can run for a week or 10 days. So Murphy's Law, if you reach it at the 11th hour and somebody else abuses that machine, that user, that group, or whatever, their work might just be, that's it, finished, pointless. So containment of users and tasks, and network-related restrictions and limitations. So what do we mean by network restrictions? I don't know, subnet or VLAN limitations, topology, things like that. Virtualization is, as everybody knows, an ideal solution for things like that. So results. Basically what happened is we got buy-in from major business groups, and that's where I mentioned what business groups mean. We're hoping that small groups will follow suit, because some of the very large ones have. Running up to 3,000 machines concurrently, dynamically spawned. Now, everybody here will say, again, 3,000 is a small number, but you have to remember that we're talking about dynamically 3,000. It means that at any given time, the number fluctuates, and it can grow, decrease. It's not static. And thinking about an environment where there were 0 of these beforehand, 3,000 is a fair amount. Mixed Windows and Linux-based tasks, and what's actually funny is many of our Linux users actually are now using the system to send Windows jobs. 5 million tasks in the past few months, and again, dynamic capacity allocation, which is the main point from the previous slide. Okay, number time. Again, some of these matters are generalized. It's just to give you an idea of the direction in which it went. And just to give you a comparison between things, again, legal matters aside, these numbers are just to give you a taste of where things go. So we've got, not much time, we've got 3 different ways in which we've tested. One is a single task, which means there's a physical host with one virtual machine spawned running one task. The next one we'll see will be multiple tasks, which is basically physical host with more than one virtual machine, e.g. more than one task running, one task per virtual machine. And the third one is the hybrid model. And the hybrid model will be that the physical host is actually running a task and running a virtual machine with a task inside. I'll just go very quickly over the numbers. The point that immediately jumps to your eyes is the matter of memory, but we all know the limitations. And again, I can't discuss exactly why these operating systems are giving these numbers, but from our experience, most of our jobs are either I/O or CPU intensive. If your job's memory intensive, I suggest you look elsewhere. If you've encountered a problem where a virtual machine is churning through the memory, maybe you should use a physical one. So just as a direction, as a general line, we can see that I/O and CPU there are nearly no difference in CPU, but quite a substantial difference in I/O. The reason being that we're trying to optimize these physical machines. Again, SSD from a few slides back. Next, multiple tasks. Again, clearly memory deficits, but we can see gains in I/O and in CPU performance. So we know that we're not hampering those two, and the previous comment about memory stands. The third model, which may be the most interesting, because not many of us thought about it at the beginning, because when we're looking at matters, again, we said we've got our cloud, we've got our virtualization, and each one of them is on their own. And then we said, okay, so we'll spawn some virtual machines dynamically on these hosts. Then why not still use the physical hardware? You don't want to limit yourself. So that's what this model does. It's basically running a task on the physical machine and one on the virtual machine. Again, in this case, it's a bit difficult to commit to which solution is best, but you have to look into what your use case is slightly. it's very difficult to generalize the solution, but again, one of these 3 buckets should fit 3/4 of our use cases. So the main challenges we saw. Improving performance while minimizing cost, that's the most important thing to anybody. Cost avoidance, saving money. Heterogeneous virtualization enclaves, you're just basically adding another virtualization option to the environment. Some people might be weary of it. You might want to try dedicate and focus in on specific areas. Increased complexity of implementation, you're adding another tremendous amount of complexity to the cloud. You're intertwining 2 very complex realms together. Full backwards compatibility. Again, we mentioned our users. We want everything to work. We've got 100,000 employees. There's a tremendous amount of automation or the way things are done that are still in place for a long time. You have to make sure you're not breaking anything when you're making significant changes. That's also the next bullet. This may be a disruptive change. Necessity of transparency for the users, and a very important point being support. And support can be the vendor external support, which for KVM and the enterprise vendors is still work in progress, I'd put it that way. And more importantly, internally, your experts who users used to come to them and say, I've got a problem with this, were usually quite focused. Now you're actually splitting it up, and you may be causing your internal experts a few problems as well. So the benefits. I won't go over the points, but basically we're adding a non-existent capability to the environment. We're reducing our carbon footprint, lowering licensing costs, and improving computation density. So basically, free, fully transparent, significant cost avoidance, simpler, and more versatile. So our next steps are wider adoption by more internal customers, improving the performance and scaling out, integration with BI, which is also a buzzword, and live migration and containers. Now, I might have said something about containers previously, but they're still an option for lots of types of tasks. And live migration has a question mark because there's still a few issues with that, the way we do things. Again, you'd like to have low-cost live migration and to improve your capabilities, which is still not there in our case. So, summarizing, we've changed the way we do things. We've integrated KVM into our cloud. We've presented quite a complicated business case. And these are all benefits, but we just have to remember that we have increased flexibility, deployment time, turnaround, faster shifts between operating systems, but we have increased the complexity of our environment. That's it.